Hello again, Verdugo. Hi, Algebra 2 students. Just to kind of recap, we did lesson 1. Last video was lesson 1 for graphing cube root functions. This is going to be lesson 2. This is going to be the last lesson for graphing cube root functions. At the end of this video, you guys will see two problems, homework problems to do. So graph, cube roots on your own. If you remember the last video, video 3 of square root functions, I gave you one homework problem. So the two that I'm going to give today would be actually titled number 2 and number 3. So total you would have 3 until now, until I make more videos for this section. Okay, so how many you'll end up with, I'm not quite sure yet, but after this video you will have a total of 3 homework problems to do, which you could just do on a separate sheet of paper. I'll talk about later about how you'll submit those, or your teacher will talk about how to submit those. So video 1, we did cube root function. We graphed a parent function. The parent function, we saw after doing the t-table, we saw, hey, it looked something like this, where it curved like this, and at the inflection point, it curved this way. Okay, and the inflection point was at 0, 0. So we're going to take this parent function and we're going to move it around a bit. So here's what I'm going to do to it. Let's see what we can do. So just kind of keep that in mind, what that looks like. Now, I'm going to take this and go plus 8 here, and I'm going to go minus 1 on the outside. So, same as always, we're going to get our x-intercept, our y-intercept, and then from there we'll move on. Okay, and we're just going to sketch this graph. I don't need to do a detailed t-table like I did last time. The only reason I do a t-table with the parent function is because I'm just assuming we don't know what it looks like at all. It's the first time we're graphing it. We just want to get a feel for it. Graph right over here. Okay, there we go. First, let's do x-intercept. As always, if we want x-intercept, we must make the y, set the y equal to 0. So we're going to do that. We're going to make the y equal 0. So this is our y. I'm going to go 0 equals cube root of x plus 8 minus 1. So what's next is we're going to have to do plus 1, plus 1. That's going to leave us with 1 equals cube root of x plus 8. Now the key, this is the important part. I can't do anything with this plus 8 here until this cube root is gone. Let's think about the inverse of cube root. What is the inverse of cube root? And so that's going to be the opposite of cubing something, of cube rooting something is cubing it. So we're going to, what I do to one side, I'm going to do to the other. So that's going to leave us with 1 to the power of 3, which is 1 times 1 times 1, or otherwise known as 1 cubed, which is 1, equals, and this cube root is going to cancel. I'm going to be left with x plus 8. Last step, minus 8, minus 8. We finally got our x-intercept here. The x value for our x-intercept is going to be negative 7. Now I'm going to jump over here and put that in. The x-intercept is negative 7, 0. 1, 2, 3, 4, 5, 6, 7. Negative 7, I could already tell. I'm probably going to need to extend this a little bit. Probably won't have enough room. Okay, so negative 7, 0, that's our x-intercept. Perfect. Now let's talk about our y-intercept. So take a look at that. Pause it if you need to. Copy that down because I'm about to erase it. Okay. Y-intercept should be a little bit easier. Okay, that's our x-intercept. Now let's go to y-intercept. So for x-intercept, we set the y equal to 0. For the y-intercept, we're going to set the x equal to 0. So x equal to 0. So let me just copy that down. So instead of writing f of x, I'm going to put y equals cube root of x is going to be 0. So 0 plus 8, that entire quantity minus 1. Notice the negative 1 is not in there. It's minus 1 on the outside of that cube root. Okay, so we got y equals cube root of 8. And all that minus 1. Let's think about it. What is the cube root of 8? What multiplies with itself 3 times to get us 8? 2. 2 minus 1, y equals 1. See, I told you y-intercept was going to be a little bit easier. So y equals 1. So our y-intercept is at 0, 1. So, one thing left over and one thing we're going to ask you. What's the inflection point? Where does this start? So again, the parent function, the inflection point was at 0, 0 because the graph went like this, curved in, and then curved that way. So it's kind of like the pivot where it kind of changes direction a little bit. So where is the inflection point going to be for this one? We're not going to do any hard work here, guys. Very simple. I want you guys to think deep down inside. If I were to give you, let's go way back machine, okay? Way back machine. If I were to give you, let's see, y equals, I'm just giving an example here. Y equals x minus 3 squared plus 4. Parabola, okay? In vertex form. You tell me the vertex here is positive 3, remember the h and k, positive 3, and positive 4. So remember, h is kind of, it's weird, it's the opposite of what you see here. So if you see a negative 3 here, if you see a minus 3 here, it's actually going to be positive 3. Well, if this was a plus 3, we would say minus 3, comma 4. Okay, that was great. And then we used this same idea for square root graphs. Same thing. The vertex for a square root graph in this case would be the same format. The vertex form is negative 3, comma 4. Great. And guess what? Same thing applies for cube roots when we want to do inflection, when we want to find the inflection point. The inflection point would be, you guessed it, negative 3, comma 4. So let's take a look at it here. The inflection point would be negative 8, comma negative 1. Now remember, it's negative 8 because it's a positive 8 in here, okay? So if this was already a minus 8, then I would just say positive 8. So negative 8, comma negative 1. That is called the point of inflection, or the inflection point is going to be negative 8, negative 1. Now let's see if this works out with my graph. It should all work out nice. Negative 8, there we go. So if this is curving up like this, and that's my inflection point, this is my inflection point, very important, then I know what's going to happen here. Going this way, it's going to curve this way and point there. And there we have it. That is our cube root function for cube root of x plus 8 minus 1. So let's rip through the rest of what we need here. We need domain. Domain left to right. X values left to right. Well, as you can see, it's going forever left. It's going forever right. Forever left, negative infinity. Forever right, positive infinity. Range, also very simple. Well, let me not just put the parentheses yet. I mean, it is going to be, but let's just. Range, going down, going up. Again, a little more difficult, but going down, it actually is going down. So if I continue this line, it'll keep going down slowly, but it'll keep going down. So forever left, and also it'll keep going up. So for the range, going forever up. That's our domain and range. So there's one thing left, guys, and that is the inverse. Okay, inverse of this. Now, I'm going to keep the inverse of this a little bit short because otherwise it'll take a little bit too long, like a little too much space. So we're going to find the inverse of f of x here. Okay, and in order to do that, I'm going to first make this y. So that's y and that's x. Let's switch the places of y and x. That'll be y. That'll be x. Now let's solve for y. Okay? So let's do this. First things first. Plus 1, plus 1. Let's rewrite this. X plus 1 equals cube root of y plus 8. Next, I can't do anything here until that cube root is gone. So we need to get rid of that cube root by cubing. What I do to one side, I do to the other. So I'm left with x plus 1 cubed equals, and so cube and cube root cancel, we're left with y plus 8. Now, I'm actually not going to multiply this out, x plus 1 cubed, because that would be x plus 1 times x plus 1 times x plus 1. I'm actually not going to do it. I'm going to leave it like this. For our purposes, this is fine. It'll suffice. as long as you understand how to multiply that, that's one thing, but I'm not actually going to do it right here, okay? We're just going to leave it as is. All right, and one last step, y is not isolated just yet. That 8 is bugging me. So let's go minus 8, minus 8. So we finally got y equals, what do we have here? X plus 1 cubed, and all of that minus 8. And I'm just going to leave like that. So our inverse of f of x is x plus 1 cubed. I'm just copying this. Minus 8. And we are done. Okay? I'm going to flip the board over now so you guys can see the 2 homework problems. And again, remember, we gave 1 homework problem at the end of the square root lessons. So now I'm going to give 2 more. So this is going to be numbered actually 2 and 3. Okay, so I'm going to flip it over now. Okay, so there you have it. Numbers 2 and 3, 2 problems to do for graphing cube root functions. Again, x-intercept, y-intercept, inflection. Again, inflection point takes 2 seconds. Domain range and inverse. Same thing here, just a separate, different problem. Same idea, nothing complicated here. X-intercept, y-intercept, inflection point, domain range, and that. And obviously I didn't mention here, but you must graph this as well. Okay, so I obviously want to be a little sketchy. Okay, all right, thanks guys.